Hey, good morning. Welcome to
KidMath number 147.
KidMath number 147. So this is going to be mystery log talk. So we can either continue talking about powers of I like we were doing yesterday, or powers with I mean, or we can do a problem like we were doing this morning out of the book.
Let's do powers of I.
You want to talk about powers of I? Okay. Awesome. So we have this fun equation, e to the pi I plus 1 equals 0, and it's famous because it has the 5 most important numbers in math, even if I didn't make my I quite right. Give me the eraser. I with a dot running away. So this is a really interesting equation, right? And we, for our section on logarithms, transform it into e to the pi I equals minus 1. Okay? But then we saw something very interesting. What happens if we square this equation? What do we get?
We get e to the 2 pi I.
Sorry. Not writing really well this morning. E to the 2 pi I equals what?
I.
How?
Minus 1 squared. Oh wait, no, it's 1.
Minus 1 squared is 1. Right. What if I cube this equation? What do I get?
E to the 3 pi I is, you mean this equation?
Yeah.
E is minus 1.
Minus 1. What if I take this equation here to the 4th power?
You get e to the 4 pi I is 1. But how can those be equal?
Okay. And it's going to keep going. What's e to the 5 pi I going to be?
Minus 1.
E to the 6 pi I?
1.
E to the 7 pi I?
Minus 1.
E to the 8 pi I?
1.
What's the pattern?
It keeps alternating between minus 1 and 1.
Right, so what powers are what's the pattern in the powers? What powers are 1, what powers are minus 1?
The odd powers are minus 1 and the evens are 1.
Okay, so when I have an odd number times pi I, which that's not an odd number, like 1 pi I is not an odd number, but 1 is an odd. When I have an integer, the integer's odd times pi I, I get minus 1. Integer's even times pi I, I get 1. Okay? That's strange, right?
Yeah.
We haven't really talked about equations or powers that are periodic. They sort of get back to where they started.
Yeah.
Okay. And this presents a very difficult problem that you don't learn about until you get to very advanced math. But I'm going to show you what it is. Okay?
Yeah.
Okay, now remember we said something simple like log base 2 of 8 equals what?
3.
3. Okay. Right. Or let's go to even simpler. Log base 2 of 4 equals
Is 2.
Okay. And that's because 2 squared is 4. Right? Okay?
Yeah.
Yeah. Or 2 times 2 equals 4.
Yep.
Yep. But 2 times 2 times e to the 2 pi I also equals 4. Because e to the 2 pi I is 1.
Wow.
And 2 times e to the 2 pi I times 2 times e to the 2 pi I also equals 4. Wait a minute. That's strange. Huh. So logarithms have a very interesting and somewhat strange problem it seems like they have to solve. Like you don't know how many, you know kind of what the numbers were, but you don't know how many e to the 2 pi i's were secretly hanging around.
Yeah.
Okay? Or maybe it was e to the 4 pi i's.
Or 6.
Or, a million. Something like that. And it becomes actually a little tricky. It actually becomes a lot tricky because I said we could use this equation to say log base e of minus 1 plus pi I. Okay. What power of e gets you to -1? Well, log base e of -1 seems to be pi I.
Hmm.
But it also seems to be 3 pi I.
Wow.
So we didn't encounter this problem when we were only talking about real numbers. And log base e of 1 should be 0 because e to the 0 is 1. Right?
Yep.
But we just saw that log base e of 1 seems to also be 2 pi I.
The eyes are messing it up.
Yeah. So it looks like log's not a function. Right? For every input, we're getting multiple outputs. In fact, infinitely many. 2 pi I, 4 pi I, 6 pi I, or in this case, pi I, 3 pi I, 5 pi I. Probably goes backwards too, right? Probably has negative numbers. So interestingly enough, this is a very difficult problem to solve. Now, we pretend when we're doing just real numbers that logs have a domain of only positive numbers and the negative numbers don't come into play. But we can see we can deal with negative numbers. They seem to introduce this very complicated problem that you don't get a function anymore. That's pretty interesting, right?
Yeah.
So it took mathematicians a long time to figure out how to deal with this. A long time. And it comes up, this idea, the ideas on how you solve this problem are fascinating, actually. And those ideas all by themselves allow you to solve other really amazing problems that you would never expect. That you would absolutely never expect. So we're not going to talk about this until you're much older. But I wanted to give you a little hint of this now. That logs with just real numbers, not too hard. Logs when you pretend there are no complex numbers, not too hard.
Yeah.
Logs when complex numbers knock on your door and show up and say, hey, I'm here. Uh-oh, very complicated.
Yeah.
All right? All right, good job this morning, huh? Good job.